picking up here on the Unit 10 exponential review with number 9. So this section, these 4 questions are looking at solving exponentials. So the only method for solving exponentials we have worked with that you've been taught that you would be expected to use on this test is the one-to-one property, where you match the base on the left and right side of the equation. Because if you have that matching bases raised to powers, you then know that the powers must be equal. Okay, that's one-to-one property. So here in number 9, my base on the left is a 7, and my base on the right is a 49. So right now they do not match. But can 49 be rewritten as a 7 base? 7 to some power? 7 to what power is 49? 7 squared. So I can replace the 49 with 7 squared. Okay, those are equivalent to each other. So I make that substitution. Now that is still to the 2x plus 1. Over here, nothing changed. I've got 7 to the 3x plus 4. So when we got to this point, we said, all right, great. Our bases now match. We've got a base 7 and a base 7. So that means that the exponents must be equal to each other. Now, on the right side, we have to understand that you've got a power to a power. You've got that 2 and then the 2x plus 1. Okay, so these two exponents must be equivalent to each other. So we can say 3x plus 4 must equal, and then that is being multiplied. So you can write that out here with parentheses, 2, and then in parentheses, 2x plus 1, or some of you will just do that distribution up here and say the 2 times 2x is 4x, and the 2 times 1 is 2. Now it becomes a basic algebra problem to solve. So we need to get the x's to the same side and the constants to the other. So I'm going to move the 3x by subtracting. So I end up with a positive x over here, which means if I'm moving the x's to the right, I'm going to move the constants to the left. So I'm going to move this 2 to the left. So I end up with 2 equals x. Now, if x was not alone, if there was a coefficient, you would still have to divide that out. But that came out to just x. Now, you can always check, does that actually work? So if I were to plug in a 2 over here, 3 times 2 is 6, plus 4 is 10, so 7 to the 10th power. And then over here, if I were to plug in a 2, 2 times 2 is 4, plus 1 is 5. And then we rewrote that, so 7 squared to the 5th, so 2 times 5 is 10. So that would also be 7 to the 10th power. So yeah, it checks out. Or you could check it in your calculator. Okay, let's look at number 10. Right now, my bases do not match. I've got 8 on the left and 32 on the right. Okay, so I can rewrite those to match. Sometimes you can rewrite just one of them. Like in number 9, we just rewrote the 49 and they matched. I cannot just rewrite 32 as 8 to a power because 8 squared is 64, not 32, right? So in some cases, you need to change both of them to be able to get them to match. Okay, so I could change them both, in this case, to base 2. If you're unsure of that, you can, let me show you in Desmos. Let me refresh your memory. You can make yourself a little table with, we said we're trying to figure out a base 2, so 2 to what power? So you can make a 2 to the x, you can make a little table with it, and you can see, okay, 2 squared would be 4, cubed 8, 16. So there it is. I can do 2 cubed as for the 8, and I can do 2 to the 5th in place of the 32, because 8 and 32 both popped up there. So I'm going to do that. So I'm going to replace 8 with 2 cubed, and I'm going to replace 32 with 2 to the 5th. There's still the x minus 1 power here, and there's still the 3x minus 2 power here. But I made those 2 substitutions. So now the bases match, which tells me that the exponents must be equivalent. They must be equal. So I can write that out. But remember, a power to a power, I need to distribute that because those get multiplied. So here that would be 3x minus 3. Here that would be 15x minus 10. Now again, I want to get x's to one side, constants to the other. So I'm going to move the 3x by subtraction. So then I'm going to move that 10 over to the left by addition. So that leaves me with 7 equals, and then 15 minus 3 is 12x. Okay, and then I would have to divide out the coefficient. So I get x is 7/12. Now I can check that. Let me show you again how to check in, oops, Desmos here. Make this screen smaller. All right, so one way to check this is to plug that 7/12 in and see if that actually comes out where the left equals the right. So let's try 8 to the, and when you are typing in Desmos and you need something more than just one term in your exponent, use parentheses. So I'm going to do 7/12 minus 1. Okay, so this is the left side. And then I'm going to do, the right side is 32 to the power of 3 times, oops, keep hitting that minus, 3 times 7/12 minus 2. And how about that? Those are exactly the same, aren't they? So even when it's not an integer, it's a decimal or fraction value that you get, you can still plug it in and check and just make sure that you're getting the same value here for the left side and right side of your equation. So if you have a multiple choice question on your test, it says which of the following is the solution, couldn't you just take the answer choice and plug it in and check if it made them equal? So that's another way of doing this if you have multiple choice. There's no reason to get this wrong because you don't know how to get the bases matching. If it's multiple choice, you don't have to even do this process. Yes, ideally you would be able to. That's what I've been trying to teach you. But in a multiple choice situation, oftentimes you can work backward from your answer choices. So you can plug in your answer choice and check it just like this and just check, did A, when I plugged in the A choice, did it make them equal? And if it didn't, plug in the B choice and check. Plug in the C choice and check. Does that make sense? The other way in Desmos that I showed y'all to check is graphically. And this will actually work even if it's not multiple choice. You can just type your equation in exactly as you see it. So this is 8 to the power, and then it is x minus 1 equals, and then it's 32 to the power, and it is 3x minus 2 over there. And if you look on your graph, a vertical line is going to appear, and where that vertical line crosses the x-axis, that is your solution. Okay, and you can see it's not going to tell you that number, but you could estimate if it was an integer, you would definitely be able to tell. Since this one's a fraction, it's harder to tell, but you can see 7/12 is 0.58, and you can see that's just after 0.5. It's just before 0.6. It's 0.58 is where it's crossing. It's at 7/12. Okay, so here, while we've got number 12 on the screen, let's try that. If I typed this in just as I see it, it's a base 27 to the power of 3x. Get rid of this. And then there's a plus 5. And then the right side is simply 8. Zoom back out. Look, there's that vertical line. Where does it cross? Okay, so I can see if it was multiple choice, I would be able to narrow it down. Well, it's between 0.1 and 0.15. It's close to 0.11, right? Would y'all agree? Now, if it's not a multiple choice and you need the exact value, then yeah, you need to be able to actually calculate this. So let's actually do the algebra and see if we get that value that it's showing us in the graph. So here in this type, when it is not, you don't have an exponent on both sides, we need to isolate first the exponential expression. So that 5 first has to come over here. And 5, that is 3. Now I need to get the matching bases, the one-to-one property. So 27 is the same as 3 cubed. So I'm going to rewrite the 27 as 3 cubed, and that's to the 3x power. Now this 3 over here, what is the understood power here if there is no power? If no power is written, what's it understood to be? Not 0, because anything to the 0 power would be 1. It's to the power of 1, because 3 to the power of 1 is just 3. Anything to the first power is itself. So if you have a number with no power, it's an understood 1 power. So that means then that I can write these exponents equal to each other. So that would be 9x equals 1. And then I would have to divide out the 9. So x is 1/9. So up here it was 7/12. Here I get 1/9. And you can check that with where we said that looks like it's at like 0.11. Well, take a closer look. See what 1/9 is. A lot of you probably know, but if you don't, it's 0.1 repeating. So yeah, that did show us the solution. It's just happened to be a repeating decimal, so it was hard to see exactly. Y'all get that? Let's try one more time. With number 11, doing it in the calculator. See if this one's not a decimal for us. Let's try one more. We've got a base 25 to the 10x plus 8 on the left. And then we've got a 1 over 125 base to the power of 4 minus 2x. Zoom out. And you can always hit home to get to your recentered here. Okay. Now this looks to be exactly at -2, doesn't it? I think the answer is just -2. That's what I would put. Now, if it was multiple choice and they were decimals, I would pick the one closest to that because maybe I just can't see if it's slightly off. Okay, or I will still show you how to solve this algebraically. Okay, but we know we should get -2 as the answer. But here, if I have a fractional base, remember I can move the term from the denominator to the numerator by making the exponent negative. So I can rewrite that as 125 to the -1. So instead of 1 over 125, it's 125 to the -1. Okay, so I make that replacement, but the bases still don't match. I've got 25 and 125, but I could make those both base 5. 5 squared is 25. So I'm going to replace 25 with 5 squared. And then 125 is 5 cubed. So we'd have 5, and it would be -3 because that -1 was already there. So when I replace that with 5 cubed, it becomes 5 to the -3. So I make that substitution. So now they're both a base 5. And I've still got those powers. Let's see, it's 10x plus 8 here and 4 minus 2x here. So again, now that I've got matching bases, I know that the exponents must be equivalent. Those must be equal. So I'm going to write that out. It's going to be, if I distribute that 2, that's going to be 20x plus 16 must be equal to, then when I distribute here, that would be -12 plus 6x. So now it's a basic algebra problem. I'm going to get x's to the left. So I'm going to subtract 6x. So I want constants to the right. So I'm going to subtract 16. So that gives me 14x equals, and then that is -28. And then I have to divide out my coefficient of 14. And that is indeed -2. That's what Desmos showed us that line at, isn't it? At -2. You'll feel okay about those solving? If you don't feel great about the algebraic process, I think you should feel good about the fact that you can just plug this in and see a vertical line go through the x-axis at your solution. Or if it's multiple choice, you can simply plug your answer choices in and see which one makes it true. Makes the left equal to the right. All right, on 13, it says for each equation below, identify the equation as exponential growth or decay. Identify its initial value, the growth or decay factor, and the growth or decay rate. Okay, so we need a vocab review right here because a lot of that sounds familiar. So growth or decay, if the equation is growth or decay, means is the graph increasing or decreasing? So growth could look like this, and decay could look like this. Okay, now that's if your graphs are above your asymptote, right? But they could also be below the asymptote. If they were below the asymptote and looked like this, that's growth because it's increasing left to right. Okay. If it looks like that, that's decay because it's decreasing left to right. So to answer whether it's growth or decay, you either have to know the base value and transformation rules to be able to visualize it, or you can just plug it in and look at the graph and say, is it increasing from left to right, or is it decreasing from left to right? That answers the first question, okay? The initial value, that's A. The initial value is your A. It's what's multiplied in front. So I'm going to just box that in on all of these. So this is A. This one, does it have an A? If there's no number in front of the base value, what's A understood to be? If there's no coefficient, it's an understood 1. Because times 1 doesn't change it. So if there's nothing there, it's assumed to be a 1. So the initial value, done. I've answered that for all of those. Now your base value is what needs to be, let's see. Let me get a different color I haven't used yet. Let's do pink. Your base value is the growth or decay factor. That's your B. That is this number that's being raised to the power. Now, the growth or decay rate, that is, we got to break down that growth or decay factor, because the growth or decay factor is the 1 plus or minus R. R is the growth or decay rate. So we're trying to figure out how far from 1 is this number. So you just subtract the number from 1 to get it. So if I subtracted 1 here, what do I get? I have 1.67. 0.67. Now, if they ask for it as a decimal, great. But if they're asking for it as a rate, that typically means they want it as a percent. So what would that be as a percent? %67. Now, is it 67% growth or decay? Growth. It's over 1. That was added to 1. So it's a 67% growth. Okay. What about this one in B? Is this number above 1 or below 1? That's less than 1, right? So it's going to be decay. Now I need to figure out how far below 1 is it. So you can subtract from 1. What's 1 minus 0.54? 0.46, right? So what is that as a percent? 46%. Is this a 46% growth or decay rate? Decay. Because that is 0.46 less than 1. Okay, what about this one? 4.54. Is that bigger than 1? Yes, it is. So my rate here, my R, is actually 3.54, which if I convert that to a percent, that's 354%. And that is bigger than 1, so that is growth. So again, this was the only one that was decay. These other two were both growth. And I could tell that without looking at the graph because it was greater than 1 versus less than 1. If you need to plug that in and look at the graph and see, is it increasing from left to right or decreasing from left, that's fine. Go look at the graph. But I can tell just by the base value. I can tell by that growth or decay factor if it's growth or decay, because it's either greater than 1 or less than 1. That makes sense? All right, we've got time for another one. All right, so in 14 here, it says to graph the function, state the domain and range in asymptotes. Okay, so In my previous video, when I went over 1 through 6 on the front, those were the graphing questions. I showed graphing by hand by knowing your transformation rules, and I showed graphing with Desmos. I think the majority of you probably would prefer Desmos, so I'm going to show that one again here. So what I'm going to do is type in my equation. As I see it, I've got -3 times 4 to the power, and then I'm going to need parentheses to get that +1 with the x up there. And then -2 is outside the power. So this is, excuse me, this is my equation. So here's my graph down here. I can see my asymptote where it levels out is at -2. And that should make sense to you. You should get that because we have talked about your asymptote is it's y equals k. So they ask you to state the domain and range and give the asymptote, I believe. Yeah. So your asymptote is at y equals k. So remember, k is what's being added or subtracted on the outside. That's your k. So y equals -2. That's your asymptote. And we can see that here in Desmos, and we can go ahead and add that here on the graph. Now I can answer this domain question without even looking at the graph. What did we say? The domain is always the domain of all exponentials is all real numbers. Okay, or you can write it as -infinity to +infinity with parentheses for interval notation. If you have an exponential equation, your domain is going to be all real numbers. It doesn't matter if it's reflected, stretched, compressed, or shifted. It will still be all real numbers for the domain. It goes left and right forever. Now, the range will change dependent on that k, where the asymptote is, and if there are any reflections. Is it above that asymptote or is it below the asymptote? So looking back at our equation over here, I can tell you that I see a negative a value. So a negative a value tells me that there is a reflection over the x-axis. It also tells me the fact that it's a 3 tells me there's a vertical stretch. That doesn't affect the range though. What affects the range is that there's a reflection over the x-axis. So this graph is below the asymptote, and we can see that over here, okay? So to get some points to graph this, remember, let me go back to that. Once you, oh no, it went away. Let me retype that. My bad. Let me see if it'll let me undo. There it goes. Okay, so once you have your equation typed, you can hit the gear right here and then get a table. Now, if these aren't the points you want to plot, you can type in whatever x values you want and it will generate the y values for you. But this should be good for us to plot some points. So there are points at 0, -14 will not fit on our graph. That's off the graph. But -1, -5. And then -2, -2.75. And that's really all I need because then the asymptote guides me. So this essentially tells me, okay, your graph is below the asymptote and it is decreasing from left to right. You can see as the x values increase, the y values are getting lower and lower and lower. So it's decreasing from left to right, and that is our asymptote. So that right there tells me my range will be from negative infinity up to -2. Because remember, range is always low to high. It's the y values. So it's going down to it's negative infinity, and it comes up here. The highest is -2. And you do not include the -2. It's an asymptote. So that's why we use a parenthesis there. The other option for how you could write that range would be to say it is the y values less than -2. Everything below -2. Now, I do believe I just realized this as I was answering this domain and range question. I'm going to jump back to the graphs on the front because I think I went over graphing them, but I don't think we listed the domain and range. We didn't. And on 3, 4, 5, and 6, it does ask for domain and range. So I'm going to go ahead and add that for all of these. Now, again, we said domain is always, always, always for all exponentials. What? What did I just say about it? It's always all real numbers. So the domain for all of these exponentials is all real numbers. Now, the range is dependent on where the asymptote is and if the graph is below, above or below. So here in 3, we already graphed it. Our asymptote is at 3, and this graph is above it. So our range is 3 to infinity, or y is greater than 3. In number 4, the asymptote's at 0, and this graph is below it. So it's negative infinity to 0, or y is less than 0. In 5, our asymptote is at -3, and the graph is above it. So your range is -3 to infinity, or y is greater than -3. Here, the asymptote's at -2, and the graph is above it, so it's -2 to infinity, or y is greater than -2. Y'all get the domain and range questions? I hope those are not missed. All right, actually, I don't think I have time to answer this one before the bell rings, so I'll stop this video here. If you need to go on to 15, you can watch the next video. And if you need to go back to any of the previous ones, you can watch the previous videos. I will point out to y'all real quick on these word problems, if you flip over to the very back,